Hey, let's do this percents practice test. If after you watch this video, you're still feeling like a little bit confused or you're not sure how to do some of these questions, you should try to see me or Mr. Wong, whoever your math teacher is, after school, maybe tomorrow or the next day or whatever. Send us an email, talk to us after class, because this practice test is pretty much identical to the actual test you'll have to take. So if you feel really confident about this practice test, you should feel confident about the actual test. But if you're still having some issues with this practice test, then you want to get those questions answered before Monday or Tuesday when you take the test. So let's go ahead and go through it. The first question says, what is 30% as a decimal? Well, converting from percent to decimal is just a case of taking the decimal point from the percent number, which in this case would be right here next to the 0, and moving it 2 spaces to the left to give you 0.30. The reason you move it 2 spaces is because this symbol here, percent symbol, literally means divided by 100. And so we're essentially dividing this 30 by 100. And when you divide a number by 100, it just moves that decimal point 2 spaces. So the answer is 0.30. It's written up here as 0.3. You don't necessarily need this 0 at the end, so same thing. All right, number 2 says, what is 3/20ths as a percent? One way you could answer this is just entering 3 divided by 20 in a calculator, and you would get a decimal answer, and then you would just need to convert that to a percent by moving the decimal point 2 spaces, but the other way, not the way we just did it in the previous question. But the hint here says, how do you get the denominator to 100? So let's use the hint as our way to solve this. The hint is trying to get you to go like this. 3/20ths, if I were to multiply the top of this fraction and the bottom of this fraction by 5, I change the denominator into 100ths. And that's really good because that's what percents are all about, right? Hundredths. And so if you have 15 100ths, that's the same as having 15%. So that's an easy way to figure out the percent on this one. Okay, so problem 1.3 says convert 0.16 to a fraction. There's lots of different ways to do this, but the way I like to think of it is in terms of decimal places, or like place values. So the 1 here is in the 10ths position, and the 6 here is in the hundredths. And since the 6 is the last digit of this decimal number, then the whole decimal number itself, the 1 and the 6 that make a 16, it tells you that there's 16 hundredths here because the hundredths is the last place used. And so we have 16 hundredths, and you write that as a fraction, 16 over 100. So that's the one I would select. All right, next it says convert 2.11 to a percent. The number 1 and 100% are equivalent. If you have one whole of something, that's the same as having 100% of that thing. So if you've got a decimal number like 2.11 that's greater than the number 1, then you know you're going to have a percent that is greater than 100%. This is actually going to be greater than 200% because 2 and 200% are the same. Like before, it's just a matter of moving the decimal point 2 places. So 2.11, I'm going to take this decimal point and move it 2 spots, and this becomes 211%. All right, and the last one of these conversions, we have 0.0942. And to turn this to a percent, we're just going to move that decimal point 2 spaces, and we have 9.42%. All right, so now let's get into some calculation stuff. This question says 60 is 24% of what number? So if you're in my class, you should recognize this as a question where you're given the part and the percent, and the whole is missing because the words what number come after the words of, and the whole always comes after the word of in these types of questions. And so, as you can see, I already have the answer here. So that's going to wind up being the answer, but let's get it. If you're in my class, you should be using this formula: whole equals part divided by percent. And if you're in Mr. Wong's class, you might be doing it more like this, where you have a table and like your X value, which is always the whole, goes over here, and your Y value, which is always the part, goes over here. And so in this case, 60 is the part. So 60 can go here and here. And then the percent, it's 24%, but we're going to convert that to a decimal 0.24 before we use it. And so if you were working in a proportional relationship, sort of like this table, you know that you need to divide by that percent or that K. It's like the same thing as K, right? In order to get back to the whole value. So whichever of these two ways you like to think of it, you're going to wind up doing 60 divided by 0.24 to get your answer. And yeah, I already did it previously and forgot to erase the answer before I started. So the answer is already up there. You should get 250 when you do that. It looks like I accidentally left the answer to this one up here as well. So, but the question says, there are 225 seventh graders at Willard. 60% of them wore Willard swag during Spirit Week. How many seventh graders wore Willard swag? And so you should see this as a question where you're given the whole value, because you know the total number of seventh graders, and you're given a percent of them, and it's your job to figure out what part of 225 is 60%. And so in my class, we would treat this as a question where we're missing the part, and we would write this formula: part equals percent times whole. If you're thinking about it like a table of proportional values, then what you have here is your X value, the whole, is going to be 225. And your Y value, which is the part, is sort of like unknown in this case. But you have your K, or your percent value, which is going to be 0.60, right? 60% converted to a decimal. And so either way, you're going to wind up doing 0.60 times 225 to get your answer. And as you can see, I already did it earlier, it comes out to 135. All right, and then this one here says, Nick Mullins is the quarterback for the 49ers. During the season, he attempted 460 passes. He completed 253 of those passes. What percent of his pass attempts did he complete? All right, so I see this as a question where we're given the whole value, right? All of the passes that he attempted, and a part of that whole, just the passes that he completed, and we need to figure out what the percent is in this case. And so you could think of it as a proportional value situation, or proportional relationship situation, where you have your X value, the whole is going to be 460, and you have your Y value, the part, is going to be 253, and you want to find K. And so like we could make a third column in this table. We'll call it the Y divided by, oops, not Y divided by K. And erase that. The Y divided by X column, because that's how we find K, right? And so you would do 253 divided by 460. Or like in my class, the way we do it is we would just use a formula. In this case, since we're looking for the percent, we would write percent equals part divided by percent. No, part divided by whole. Geez, I'm confusing myself. Part divided by whole. And so you're still going to wind up doing the same thing, 253 divided by 460. No matter how you like to think of the method for solving these questions, in the end, you're gonna wind up doing 253 divided by 460. And I don't have the answer to this one yet, actually. So I'm gonna open up a new tab, Google tab, and I'll just have Google do it for me. 253 divided by 460 equals 0.55, which after I convert it to a decimal by moving the decimal point, sorry, convert it to a percent, I mean to say, after moving that decimal point 2 spaces, is gonna get me 55%. But there's already a percent symbol in the little box here, so I just type 55. All right, let's go on to the next one. So it says a lamp originally cost $75. Krishna has a 10% off coupon for the lamp. And then after the coupon, then the sales tax is applied. I actually don't think that's how I do it in real life, but that's how we're gonna do it in this question. Will she pay more than $75, less than $75, or exactly $75? So you should remember from one of the Desmos lessons we did in class, where they asked essentially the same question, it comes out to less than. And in these situations where you have the same percent decreasing something and increasing something, it will always turn out to be less than the original starting number. And that's because when you go to decrease something by the 10% in this case, or whatever percent it is, as long as the increase and decrease are the same percent, the decrease percent will always be taken from a larger value, right? Because you're starting from a higher number. In this case, the 10% off happens first from the $75. So that's gonna be $7.50. So now you're down to like $67.50 or something like that. So when you increase that by 10%, you're not going to increase it by $7.50 like when you went down. You're only going to increase it by like $6.75 or whatever. So you won't get back up to 75, and it always happens that way. So I'm going to click less than. That's only true if the percent decrease and increase are the same percent, though. They were both 10% in this case. If they were both 15%, it'd still be less than. If they were both 82%, it'd still be less than. It doesn't matter what order you do them either. It doesn't matter if you increase or decrease first. All right. So number 10, or slide 10, problem 6. It says a pair of shoes is priced at $76. During the holidays, the store is offering an 18% discount. With the discount, what is the sale price of the pair of shoes? All right, so this is a percent decrease question. And in my class, the way I'm hoping that students do this is still by thinking of it as, so you have the whole value, in this case, the 76, right? We think of this as our whole, or our original number, the number you have before you increase or decrease it by any percent. And this represents 100% in this question, right? Like that's like the 100% price. And then you have a percent decrease. And the first thing you've got to do is figure out, like, so I'll write step 1. What is the final percent? Because when we do the math for this one, we don't want to use 18%. We don't care so much about the fact that it's an 18% decrease. We want to know what is the percent at the end of all this thing. What our new price, what percent of the original price is that going to be? And the way you do that is by thinking about the fact that you start with 100% of the price, and you're going to take 18% of the price away. So 100% minus 18% equals 82%. This is the percent we really care about. And now we're in a situation where the question is like exactly the same as the ones we just did previously, just it has this one extra step where you have to figure out what percent you're going to use. But now we have a question where we have the whole, right? The whole is up here. And we have the percent that we're going to use. So we're missing the part. So we would use the formula part equals percent times whole. Or you could put it in a table like this, think of this as your whole side over here. Think of this as your part side over here. You've got your whole value of 76. We now know that our K that we're going to multiply by is 0.86, or sorry, 0.82. And we just want to find that Y value or that part. So either way, you're going to end up doing, what is it, 76 times 0.82. 0.82. Let's see what that gets us. 76 times 0.82 equals $62.32. So not all these questions, what was it again? 62.32. Not all these questions are going to come out to perfect whole numbers all the time. So if you're working on the test or whatever, you know, don't necessarily freak out just because your answer came out to a decimal or whatever. So for me, what I like my students to do when they're asked to explain their thinking is just show their work in the box. You could show your work by like drawing all this stuff that I just drew on the screen, like in the sketch box here on the left side of the screen. Or if you prefer, you can type it into the explain your thinking box. Something that I would accept as a full credit answer would be like, okay, the original price is 100%, and 100% minus 18%, oops, I don't know, percent minus 18% equals 82%. I don't know why I typed 28 instead of 82%. Okay, so that's like this, essentially what I wrote for step one, right? So then the next thing we did was just $76 times, you can get that multiplication dot when you're typing by holding the Alt/Option button and pressing the 8. So 76 times 0.82 equals $62.32. So, and that would be a good explanation in my mind, because you're just like essentially just showing your work. All right, let's go on to the next one. A car is 120 inches long. A truck is 14% longer than the car. How long is the truck? All right, so this is a question where we're given the whole, or the original number. The 100% value in this case is going to be this right here. So original 100% right there. And then this is our percent increase. Percent increase. Increase means something's going up, right? It's getting longer. It's an increase. All right, and so our first step is figure out what percent do we actually have here. We start with the original 100% length of the car, right? And we're measuring something that is 14% longer than that. So we need to add on an additional 14%, and we get 114%. So this is the percent that we really care about in this question. Now we have a question where we have the whole and the percent. We're looking for the part. And so part equals whole times percent, or you can set it up in a table and think of it as you got your whole over here, you got your part over here, and the whole was 120. Our percent, or our K value in this case, is going to be 1.14, because I just took this 114% and converted it to a decimal, 1.14. And either way, in the end, you're going to wind up doing 120 times 1.14. I don't know what that is off the top of my head. It's probably somewhere in the neighborhood of like 126 or 136, I mean. Let's see. See how close my guess was. 120 times 1.14, 136.8. Oh, yep, there it is right there. And so I'm not going to worry about typing anything out or drawing anything out. You could show your work, if you were on the test, you could show your work by like drawing all this stuff that I have on the screen, like in the drawing box here, or just typing your work out similarly to how I did in the previous question. Okay, problem 8. A store is offering a 25% discount on all items. Okay, so that's going to be a percent decrease, right? Discount, decrease, lowering the price, whatever you want to say. The price of a hat after the discount is $26. So this is like my new number or my part, right? This is a part of what that original 100% price was before the 25% got taken off. So this is after the 25% got taken off. So if I'm thinking of it like a table like this, I'm thinking, okay, my whole or 100% value, that's the unknown in this case. The part or the new value, that's the $26. And then I got to figure out what percent is it that's actually connecting these two values. And so over here, I'm going to think, okay, the original price, whatever it was 100% of the price. And then a 25% discount got taken off. So what's left here is 75%. The $26 is 75% of the original price. And so to work backwards to that whole value, I'm going to divide by 0.75. Or you can think of it as this formula, the part equals the whole, sorry, no, not the part. I knew that didn't feel right as soon as I said it. We're looking for the whole or the original value in this case. So it's going to be the whole equals the part divided by the percent. And either way, you should wind up doing 26 divided by 0.75. I'm not sure what this one's going to come out to. Maybe like 34 or so, 32. Let's put it in a calculator. 26 divided by 0.75. Ooh, that's ugly. Look at that. Did I do that right? 26 divided by 0.75. 26 divided by 0.75. Yeah. No, I guess we just round this up in terms of like what answer we actually put in here. So the calculator is giving me $34.06 repeating cents. So I guess it'd be $34.67 you would round it to. And so to show your thinking, you could just show all the work that I have drawn on the screen, or you could type it out, type out work similarly. All right, number 9 says, Mr. Thomas is picking up a pizza for his favorite math class. I don't have favorite classes. The pizza cost $30. After the sales tax is added, the grand total now is $32.40. So what was the sales tax? And so this is a question where we're given that original value before the percent increase or decrease, right? So you can think of this as your original or your whole or your 100% value. And then we're given this like new value here. You could think of this as a part of the original 30, or like we know it's a different percent than 100%. And that's the thing we're trying to find in this case actually, is what was this percent increase? We know it's a percent increase because the price got higher, right? It went from 30 to 32.40. And so we could put it in a table like this with our whole and our part, and the whole in this case would be the 30 and the part would be 32.40. And then you're just trying to figure out your K in this case would be the like the percent. And so if this is your X and this is your Y, you need to do Y divided by X. And if you're in my class, we would just think of it as this formula, percent equals part divided by whole. And so either way, you're going to wind up doing 30 divided by 32. Nope, wrong way. Messed it up. Geez, I made a few little mistakes in this video. So make sure you're doing the part which is the newer value, the 3240, divided by the whole, which is always the original value before you do any percent increase or decrease. So we want 3240 divided by 30. And so this should come out just a little bit bigger than 1, or probably like 1.0 something, I'm not sure. And so let's see. 3240 divided by 30, 1.08. And so that's the same thing you would get over here if you did your y divided by x. And so there's still an extra step if you're using this solution method here though, because 1.08 equals 108%. But you don't want to say that the percent increase here, or the sales tax in this case, was 108%. That would be a ridiculous amount of sales tax. And also, that doesn't make any sense. If you increase something by 100%, that's the same as doubling it. So if the percent increase here, the sales tax was 108%, then that original $30 would have had to have been like $65 at the end. And so when you get this answer of 108%, you have to think about one last step. You have to think, okay, well, I only care about how much it was increased by. I don't want to count that original $30, which was 100% in this situation. And so you have to take away that original 100%. You're left with just the 8%. That's the part that was actually increased. That's the sales tax in this case. Another way you could do this question is, instead of thinking as the new value as the part and then having to subtract that 100% at the end, you could just think, okay, how much did the price actually go up by? Let me treat that as my part and see how much that is worth. So for example, the new price was $32.40. If you subtract the original $30 off of there, so either way, you're going to wind up subtracting the original amount out of the question. Either you do it beforehand or you do it after, right? In my first method that I already showed you, I wound up having to subtract 100% at the end. This method, I'm having to subtract that $30 off at the beginning. Either way, that original amount has to get subtracted either as 30 or as 100% somewhere in your solution method. So if you do it this way, you're left with $2.40. That's the actual increase, right? And so then if you represent that $2.40 as a percent of the whole value, always taking percents of whole values, never like new values or parts. So $2.40 divided by 30, it should get you 0.08, because you should get the same answer, right? But see, this way you don't have to subtract the 100% at the end. I guess I should say that equals 8%. You just have to subtract the 30 at the start. So either way, you're subtracting somewhere. All right, and then the last slide says, Mr. Wong is eating at R&R Sushi and gets food for him and his wife. He leaves a 24% tip. Mr. Wong's such a big tipper. And the total for food plus tip comes out to $102.30. What was the total bill before Mr. Wong gave the tip? So this is a question where we're given the new value for the part, because that's always the number like after the percent increase or decrease happened. And we're told the increase percent, right? Because a tip increases the bill. It's like extra that you pay for the server, the waiter, whoever helped you. But remember, when you're doing these questions, it's not the percent increase percentage that you care about. It's what's the total percent when all is said and done that you care about. And so step one for me would be to do 100% plus 24% equals 124%. So what Mr. Wong really paid at the end of this was 124% of the original bill. And this is the percent we care about. And that's going to equal 1.24. We know we're going to need that number. So, and now since this is a question where they've given me the new value or the part, and the whole is what I'm looking for, that original amount, in my class, we would use this formula: whole or original equals part, which we also sometimes call new, divided by percent. Right, so we have like multiple words that mean the same thing: whole and original, part and new. Or you could put it in a table and think, okay, whole over here, part over here. The part is going to be that 10230. And you know you got to divide to get back to the whole value, which is, and you're going to divide by 1.24. So either way, to solve this one, you should be doing $102.30 divided by 1.24. And let's go ahead and see what that gets us. 102.30 divided by 1.24, 82.5, which would be $82.50, not $80.05, right? The 0.5 was in the tenths position, so it's like having 5 dimes. All right, and then when you submit it, you got to submit and explain. And so, you could explain by putting all this work that I'm showing like in the drawing box here, if you like doing it that way, or type your work out that should essentially show all the same stuff that I've drawn on the screen. All right, that's about it. Good luck on the actual test.